Hey, pre-calculus, this is our introduction to our new unit. And I know you're only watching one video, but this is actually take 3. Can't promise it's not going to mess up, so bear with me. So what we're going to look at here today is going to be conic sections. Now, really what this is, we're going to be talking about 4 different shapes. And we're only going to focus on one at a time and try to answer every question we can within each shape. But these conic sections are created from essentially planes intersecting the shapes you're looking at right here. These are called double napped cones. And let me start writing on the screen here so you can see what we're really talking about. The first shape comes from when we have a plane that intersects this double napped cone like this, and it's parallel to the base of one of the cones. It could be on the bottom cone or the top cone, it doesn't matter. Now what shape comes from that, if you were to take a cross section, it's going to look something like this. And as long as we're parallel to the base, really it's the same shape as the base, but it's just smaller. The closer we intersect or slice the cone, the closer to the apex right here, the smaller the circle is going to be. And so the cross section is going to be just a circle. Okay, so we should be familiar with circles relatively from geometry. The next shape is when you have the cross section that's not going to be parallel to the base. It's going to be kind of at an angle. So imagine we're slicing this way, and your cross section would look kind of like an oval. It's not going to be exactly the same shape as your base. It's going to be a little bit slanted. And what that does is it creates an oval. But we have a name for this. This is called an ellipse. And the third one is when you have a cross section going from the top base down to the bottom base. So essentially it's a vertical slice like this. And that is going to create shape like this. And if you were to look at that cross section, it would just look like 2 outward facing parabolas. And this is what we call a hyperbola. And the last one is when you intersect or you slice the cone on top or the bottom, and you hit one of the sides and then also the base as well. So if you look at the circle and the ellipse, the slicer is going from side to side, not hitting the base. So this one we're gonna slice at an angle, and it's going to have a flat bottom, and then it's going to curve up like that. And really what you're creating is that shape, very similar to the hyperbola. And it's going to have, well, you can see that. Hopefully this visual is helpful, but we'll get into the shapes more. This is called a parabola. And from Algebra 2, you have studied parabolas. Okay, so these are the 4 shapes we're going to look at. We're going to talk about their equations, their properties. The first one we're going to focus on, though, is just going to be the circle. Okay, so something we're hopefully familiar with, and as this remote learning continues, the process of it, we're hopefully going to make this enjoyable for you. So let's move on now to some vocabulary. So looking at just our first two shapes here, the circle and the ellipse. So for the circle, we have a center, and this is at point F. Okay, you can see that right in the middle. And we have a radius, which is the distance from the center out to any point on the circle. In any direction, it should be exactly the same. Okay, those are all a length of r, I'll say. And now it doesn't have to be at the center doesn't have to be at the origin. It can be placed anywhere. And that's really the only attribute that we talk about, is the center and the radius for a circle. Now for an ellipse, we talk about these 2 points right here. Okay? It has 2 foci. And as you look at the 2 images, the left and the right, this is what we call a horizontal ellipse, and this is what we call a vertical ellipse. And some of the properties we talk about here, because for the ellipse it doesn't have a radius, but it does have dimensions. It has dimension going horizontal, or it has a dimension going vertical that will be the longest distance across that ellipse. And this is called the major axes. Okay, so one thing to remember is the major axis is the longest one. And then the other axis is the shorter one. And we call that the minor axis. This is the shortest. And we have vertices. So there are co-vertices and vertices. The vertices are along the major axes. Okay, so we're going to have vertices that go along with the major axes. So you can see here's our vertices. And then our co-vertices would be along the minor axes. So this will have co-vertices. That would be along the shorter axes, which would be on the left and the right of my vertical ellipse. So now I don't want to get too far into the other shapes, but we should just talk about, all right, do the other shapes have foci? Do they have a center? Do they have axes? Like, what's the language involved? So I'm going to exit this writing, move down to the other two, the hyperbola and the parabola. These essentially just have foci, and there's not really an axes. They have vertices, but that's pretty much it. So let's just skip those for now, because I'm gonna do more detailing with that later. Like I said, we're focusing on just circles today. We did talk about the ellipse and just some vocabulary, but I'm going to focus this video on just circles, and you will have an assignment as well just on circles. Okay. So looking at the equation of a circle, if you remember from geometry, it's easily identifiable to find the center and the radius. So if we look at these examples, the center of the circle is right here. The center of the circle is at -2, -4. Now looking at the equation, notice that the x value the number you're adding on to the x is 2, but the x value of the center is opposite that value. And that pattern goes along with the number you're adding to the y. It's 4. Okay, well, it's the opposite of that value for the y coordinate as well. How long is our radius? Well, our radius is only 2. So does that mean that it's half of this number? Okay, well, let's look at the next example. The center here is at -1, 4. Well, that is the opposite of both of the values you're adding to the x and y in the parentheses. The radius now is a length of 3. Well, that's not half of 9. And just using some pattern recognition, you can see that it's really the square root of that value that'll give you your radius. And here it's going to be 3. So moving quickly through this, the center here is going to be at 0, -2. So notice that if there's nothing added to the x value, then it's just going to be 0. It's the same thing as writing x minus 0 or x plus 0 squared plus the rest of the equation. Okay. I'm going to skip down now because all of these are very repetitive. And you can print these out and you can work through these. There's an answer key as well, but just some guided questions. Looking at the radius of each circle, where is it represented in the equation? So in general, let's start on number 4 because this is going to relate back to number 2 and 3. In general, the equation is x minus h squared plus y minus k squared equals r squared. So the radius is always located on one side of the equation, but the actual value of the radius is always squared. So, for example, if you have x minus 1 squared plus y plus 2 squared equals 5, well, the radius here is actually the square root of 5, okay? So make sure that you're going to be square rooting that if you're finding the radius. And the center of the circle is always the opposite values of the numbers in the parentheses. Okay, so just identifying the center and the radius, and that's really all we'll be focusing on here for circles. So on the next page, what I'm going to ask you to do is I'm going to ask you to pause the video, okay, and I'm going to have you try these problems, and then you can unpause the video and check them, okay? Or if you just want to watch it, just watch it. This document is uploaded and you can go right to this page and try it on a separate sheet, or you can print it out for yourself. Okay. Actually, change of plans. My video, it can only be 15 minutes. So I'm going to have you try this page out. And then go to the answer key and just check them. And then our next meeting, we will be Zooming. So we can answer any questions we have on this document for circles. All circles only, no ellipses yet. That'll be next week. And then I'll have some extra practice for us too, maybe a quiz or a Kahoot, and then we can touch base. So hope all is well, everybody. Stay safe and be healthy and take care of one another.